Okay, I wanted to draw your attention to this announcement that I put on last week. Just quickly, this takes effect Wednesday. So we're just not going to have any more late homework. But then to compensate you for sickness and things out of your control, I'll drop some at the end. Okay? So it's due at the beginning of class on Wednesday, and then if it's late if it's middle of class or end of class or after that. But again, you have a cushion for things that are out of your control. Okay? So we'll go with that from here on out. And then also, in terms of getting the folding and the heading right, it's very easy to do, but it's always my experience that some students need a little motivation. Okay? It makes a tremendous difference for me if they're all the same this way. So very easy to do. If you mess it up, we'll start docking some 25% of your earned score. Okay, so just do it right. It's easy. Okay, and it helps me a lot. Any questions? And we'll start that Wednesday. So homework's due at the beginning. So be on time too. If you come late, then I'm not going to accept it. So be on time. Questions about that? Okay, we'll just jump right in. Oh, we got our exam Thursday, right? So we're right on track for material. So the stuff we do today and Wednesday is definitely all important for the exam. And then I posted, I was going to talk about Blackboard, wasn't I? Okay, let's see here. What am I doing? Oh, I'm already here. What am I doing? Okay, I'm already here. So I set up this new area here on the left called Exam Preparation. Click on the folder. So the first thing is an outline. That is a comprehensive item. Okay, that outline covers everything the exam will cover. Then I posted some sample exam items. This is not comprehensive. This is just to give you a feel of the multiple choice on the exam, what they're like. Okay? So that's just to give you a feel. The content of those does pertain to the content of the test, but it doesn't cover the whole test. Then the web work I've got going. Okay, if you go to webwork.asu.edu, I showed you, click on my name in the 170 column, and then I made it for bonus. You got to get whatever you're going to get done. You got to get that done by Wednesday at midnight. There's 42 problems. Get going soon on it. Okay. Again, this is not meant to be all of your studying. It's just meant to be something different to give you immediate feedback. Okay. When you study, you're going to want to study the things I've assigned from the workbook in class and the homework problems. Okay. Yeah.
For the online credit, is that all extra credit?
It's extra credit. If you don't ever go there, you won't be penalized. But if you do them all, then you'll earn yourself some extra credit. Okay, so I recommend it, and it's a nice way to study because, like I said, you get the immediate feedback. You know that you got it wrong or you get it right, and it helps you.
You have to see all of it.
No, nope. You can do part of it if you want. Yeah, yeah, sure. Yeah, because no one's going to get them all right. So yeah. Okay. Then I posted this quiz archive. Actually, that's last semester's quiz archive because we didn't have the same quizzes, so it's all good. Okay, I think one of them is common with the ones we took, and there may be one or two that are different, but great practice. Okay, that's all good for studying. Any questions on the exam on Thursday? You know, obviously, don't wait till Wednesday night. Get going soon. All right. Lots of materials there to help you study. Okay, and then as you have little questions about web work, so on some of the web work problems, you get 5 attempts, and some of them you just get 2 attempts because it's like true or false or multiple choice or something like that. So just be really wary if you're really going for that bonus. Be really wary of how many attempts you have left. Yeah, so any questions on that? All right, then we'll just jump right in. You're gonna work on page 109. So 109 is talking about, this is a Fahrenheit function, okay? So the formula to get Fahrenheit for degrees Celsius is 9/5 C plus 32. So we can make a function, they're calling the function G. The input to G is Celsius degrees. And the output then, there's the rule that operates on Celsius degrees. And so the output is Fahrenheit. Okay, so the first couple questions are a nice kind of review and warm up. And then it'll kind of lead us into the new topic today, which is inverses. Okay, so just do number 1. All of number 1 on page 109. You can work together. Okay, g of x equals 212. So then what does 212 represent? What kind of number is 212? Degrees in Fahrenheit, she says. Agree with that? Is it the output or the input of g is 212? Output, which has to be? Fahrenheit, right? So that's Fahrenheit. And so what are we asking for? We're asking for the value of Celsius that corresponds to 212 Fahrenheit. So you could just we're asking for the Celsius that if it went through the function would output 212. And what is that? What's special about that? Anyone know what's special about that? 100 degrees Celsius, 212 degrees Fahrenheit. It's boiling, right? Boiling point for water. Okay. So now they want us to find a function that converts an object's temperature in degrees Fahrenheit to its Celsius counterpart. Okay. So what will the input into H be, and what will the output be? Input into H converts Fahrenheit. So it's going to take Fahrenheit and it's going to output Celsius. Okay? So if we know that F, am I still on the screen? Can you read that? I'm still on there. Is 9/5 C plus 32, then what do we need? We need something that will give us C for some rule pertaining to F. So how are we going to do that? How are we going to get C equals some set of instructions on F?
5 minus F minus 32?
And how'd you get that?
Well, I guess they're inverse, like, so you do the opposite. Like, if you're solving for F and, like, your input is C, then when your input is C, you do the opposite, you have to go backwards.
Okay? Yeah, exactly. That's exactly right. How do we get that rule? So where does that rule come from? I'm just asking how do we come up with this rule? What's that? We got to solve for C, right? So first step is subtract 32. Can we do them both at once? Subtract 32 and then divide by 9/5 or multiply by 5/9. So there's that subtract by 32 step, and then we'll need that whole thing times 5/9 or divided by 9/5. Okay, so our HF function is 5/9 of F minus 32, and that will output Celsius given Fahrenheit. So let's just talk about what this would mean. So that the h function, what does the h function do? It takes in what? Fahrenheit and output Celsius. That's the h function. And then, what does g do?
Take Celsius. Gives you Fahrenheit.
So how these machines are very closely related. How could you describe how the one machine relates to the other? Well, what is that though? So
One produces the, you take the answer of the other and it gives you.
yeah, that's right. No, you got it. So
You take the answer from the one and it gives you the input of the other and vice versa.
So if we think about machines, like if we think about a machine, like this machine, you put in F, it cranks out C. How does this machine compare to that one? Yeah. Okay, right. So it reverses the process. It reverses. So the idea of you guys are saying inverse. The idea of an inverse function is that it's the reverse process of the first one. And like he said, if you have inverse functions, output and input are switched. Now the input before was F. In the inverse function, the input is F. In the inverse function, the output is F. In the original function, if the output is C, the inverse function, the input is C. So, g of h of 212 says to do what first? What does that say to do first?
Find the output of H.
Is it the h function first or the g function first? H is first. What are we putting into h? 212. Okay? And some Celsius is going to come out. And then it says take that Celsius temperature and do what with it? Put it into G. Which gives us Fahrenheit. Exactly. It takes you in a circle. If you go through a process and then take the result of that and go through the reverse process, what will you end up with? What you started with. That's the idea of inverse functions. If you take 212, put it through H, it's going to give you Celsius. Then its inverse is going to take the Celsius and reverse it, and you're going to end up with 212. So what if I did... What if we put 50 degrees Fahrenheit in? I'm going to put 50 degrees Fahrenheit into H. So then what is G of H of 50?
50.
They're saying it's 50. Is it 50? Yeah. Right, because you're putting it through a process, and then you're putting through a process that's exactly the reverse of that, the inverse process. It's going to spit back what you started with. Okay? What if I start with something in the G machine first? I think, suppose I put 20 degrees Celsius into G. What will come out? So I'm going to put 20 into G. I'm going to get some Fahrenheit temperature. What if I take that Fahrenheit temperature then and put it into F? It's going to give you 20. So now I'm taking 20 degrees Celsius. I'm getting the corresponding Fahrenheit temperature, which is G of 20. If I put that into the H machine, it's just going to reverse it and give me back 20. So let's see this. Let's see how it works algebraically. We'll just do one of them. Do we want to do G of H of N or H of G of K? Doesn't matter. H of G of K? Do H of G of K. So H of G of K would be, what is it that we're putting into H? Okay, and what is G of K? What is G of K? How can we represent G of K? It's from the problem. It's just some number that's going into G. So what kind of number is it if it's going into G? Celsius, okay? It's a Celsius, and so what does G of K then represent for K degrees Celsius?
9/5 K plus 32.
Yep, so we're gonna use this, and the input is K degrees Celsius, so the output will be 9/5 K plus 32 degrees what? Fahrenheit. So we're now, is this valid input into H? Is it the right kind of number? Yeah, it's Fahrenheit. So what does that say to do? It says take H of that. And the H function is? It says take the input, subtract 32, and multiply by 5/9. So that's what we're going to do. We're going to take 5/9 of the input, 9/5 K, plus 32. So let's make this bracket here. And then minus 32. Do you see what I just did? I put this input, this whole thing is the input into H, so I'm applying this rule. 5/9 of the input minus 32. 5/9 of the input minus 32. Any questions on that? Does it make sense?
So when you say what do you describe the relationship, would you say K and inverse?
Yes.
Like some
Yeah, they're the reverse process. Inverse is this name that we give it. Yeah, inverse is this name we give for a process that's the exact reverse of a given process. That's right. Okay, so now what happens when we evaluate that? So what happens? Yep, 32. So we got plus 32 minus 32. Those go away. And we're left with 5/9 of 9/5 of K. That's right. Does it make sense that it should be K? K is the degrees Celsius, gives us a Fahrenheit. If we put that Fahrenheit into the reverse process, we're going to get the same Celsius that we started with. Okay, questions on this?
Did you have to do that whole thing for G of H
Yeah, so they're saying then do it again for G of H of N and show that you're going to get what in the end? What should you get? You should get N. You should get N. So that you can do that on your own. Okay, can I erase this page? Okay, so that's what we said. Okay, so this is two functions are said to be inverses of each other if one composed with the other always gives you the value you start with. That's what we just showed. Okay, so u and v of x are inverses if u of v of n equals n, and v of u of m equals m. Okay, another way to think of functions that are inverses of each other is that the function undoes, each function undoes what the previous function did. Okay, so the one function started with Fahrenheit and gave Celsius, then its inverse is going to undo that, undo it. It's going to take Celsius and take it back to its original Fahrenheit. So our notation for that is, given the function fx, say fx outputs capital A, okay? Then the inverse is denoted f minus 1, okay? This is not, notice, it's not 1 over f. It's important. You may be used to that being 1 over. In function notation, it doesn't mean 1 over, it means undoes the process. Okay, so what kind of number then goes into F inverse? If I've defined f of x equals some output A, then what kind of number would go into F inverse? A. So the kind of thing that F inverse takes as its input is the output of F. Okay? And so what kind of thing then goes into F?
B.
The output of F inverse. This is the idea that if we reverse the process, that input and output get switched. Okay, but we generically use X always to mean input, or we conventionally will do that. So you got to see that X here, it's not the same kind of, it's that X then represents values of output of f of X, not input. It's just that we always use X to mean input. Does it make sense? So this X here, we see it as outputs of F. Okay, questions on that? So what is F of, or F inverse of F of 20? What does this say? It says put 20 into F and get some output. It says take that output and put it through the reverse process, or the process that undoes what this did. So you would get? That should be negative. That's the inverse. That's negative 6. What about this? F of F inverse of negative 6. Negative 6. Because there's some output of the inverse function that now we're going to do the reverse process. And now F is going to undo what this did and get us negative 6. Okay, practice. So is there some blank space around there? So if you have your own notebook, you can do these in your own notebook. Okay, these get tricky, okay? So you got to really keep track of output and input, okay? So F is the number of people expected at a local concert if the temperature is X degrees Fahrenheit. So what's the input into F?
Temperature.
What kind of thing is the input into F?
The
Degrees. And what's the output?
number of
People you expect at the concert for that temperature. Okay, what's the input into G?
Or revenue.
number
Yeah,
of
which? People or revenue?
number of people.
People. That's G of X is the total revenue if X number of people attend. So the output of G is total revenue. So I've got a bunch of expressions here. Some of them make sense, some of them are valid, and some of them don't make sense. They're invalid. So you're going to figure out, first of all, is it valid or invalid? Does the expression make sense? And for those expressions that do make sense, you're going to interpret it. What would that value represent? Or in some cases, what would X represent? Okay? Great practice, okay? Talk these out amongst yourself. What page is that? The blank one. If you don't have your own notebook, 100 is a blank sheet. If you don't have your own notebook, 100 is blank. Talk them out. So these are really good practice, and they're not all simple.
So. Because regular F would be finding the amount of people. So if you're trying to find the inverse, you need to plug in the amount of people to find the degrees, right?
What is G of 100? What is G of 100? G of 100 is invalid?
That is. That'd be the number of people who showed up.
I've heard people and revenue. What is it? It's revenue. It's the output. It's the amount of revenue for which revenue is it? 100 people show up. Okay? And so now F. We're going to take the revenue for 100 people and we're going to put that into F. No, what is F? What's F's function? It does what? It takes degrees. It rejects anything else but degrees. Not valid. Okay? What is 100 here? It's the output of G. Do you see that? Revenue. So this is $100 of revenue.
Wouldn't it be $10,000?
Sorry, yeah, 10,000. Thank you. 10 times 10 hundreds, 10,000. Right. Okay, so this is the amount of revenue. And so then what is the input into G?
The output of F.
The number of people given temperature.
This is a number of people that would give a revenue of 100. Is the number of people also the output of F?
Yes.
Yes. So this is valid. And so then X represents
Degrees and
the temperature, the input that would result in that many people that would result in hundreds of revenue. Does it make sense? Just really practicing your process view of function. The 100 is the output of G, which is revenue. So the input of G is, that must be a number of people, which is also must be the output of F, which it is. And so X then is the input of F, the temperature leading to a number of people that would lead to that much revenue. So B, we're good with B. That one's no good. But X, basically, and so all in one step, X is the temperature that leads to a revenue of $10,000. X is the temperature that leads to a revenue of $10,000. Okay, what about this? So what does the 70 represent? This is the input into inverse, so it must correspond to the output of F, which is number of people. So what does that whole expression mean then? It's the temperature when 70 people attend. Or the expect. If we expect 70 people to attend, this is the temperature we would expect 70 people to attend at. Why? Because this is the output of F inverse is the same quantity as the inverse of F. Sorry, the output of F inverse is the same quantity as the input of F, which is our degrees Fahrenheit. So this is the temperature associated with 70 people. Okay, how about this?
So, hold on, this one.
Yeah.
The 70 represents the number of people, correct?
It's the input into F inverse, so it has to be the same as the output of F.
Okay.
The output of F is number of
Which is
people.
the number of people. Okay.
So the thing that I put a box around, what quantity is that? That's the output of F inverse, so it must be the same as input of F. So the whole thing is the temperature associated with 70 people attending. Okay, this one. What is 85?
The money.
Is it number of people or is it total revenue?
The inverse, so when the output is normally the revenue, then the inverse would be people.
Okay, so is it the output or the input of G inverse?
Output.
The output of G inverse, therefore, it's the same quantity as
The input.
input. So those who said number of people were correct. This is number of people. So what is X in this case then? X?
And the number amount of revenues.
Yep, it's an amount of revenue corresponding to 85 people attending. Can you rewrite this one in terms of G? Rewrite D in terms of G. Can you do it? So rewrite the expression of D, rewrite it in terms of the function G. Go. Use G to write the same thing that's communicated in part D. Use the function G. It would be G of 85 equals, that's it. Okay, now they get hard. G inverse of 95. What kind of number is that?
That is the amount of people. The whole function is the amount of people who should
That'll give you the number.
It's the output of G inverse, which would have to be the same as the input of G, number of people. Does F input number of people? No, F inputs degrees. No good. So G inverse's output is number of people, the input of G. Okay, so then we're trying to put the number of people into F. Okay, how about this one? Well, now we're getting hard. All right, G inverse of 80. So that is
the number of people.
Number of people associated with $800 revenue. Okay, so this is number of people. Can that be the input into F inverse?
Yes.
Because that should be the output of F. It's the output of F. So it works. So the whole meaning is an output of F inverse, which is, what's an output of F inverse?
Degrees.
Temperature. Output of F inverse is temperature because temperature is the input into F. So this is the temperature associated with $800 of revenue. This is the temperature associated with $800 of revenue. Question? Okay. Request. So we don't have time to do all four. Can we do? Maybe we can do a couple of them. Request. Which one of you? Someone's dying to do. Which one? I. Let's do I. Okay. What would 105 represent, first of all?
The output of inverse of G.
Output of the inverse of G, which would have to be
People.
number of people. Now let's see if this works. Okay. The output of F inverse would have to be temperature. It's the same as the input of F. The output of F inverse is the same as the input of F. Is the input into G inverse temperature? And that's the same question as asking, is the output of G temperature? No. Doesn't work. We got time for one more. J. 75 is what? Input, output, G, F, output of, so it is revenue. $7,500. Okay? What is the output of F inverse? Temperature. Is temperature the input of G? Doesn't work. Which one of these two works, G or H? Does either of them work? People are saying both. I don't think both work.
G would not work. Because, oh wait, no. Yeah, F doesn't take F inverse.
Write them down. Keep working on them. Homework is due Wednesday.
Inverse F.
Nope.